Hello everyone, my name is Andrew Fung. So today I'll be showing you how you can plot COVID-19 cases by country using a library inside Python called the bar chart race. So as you can see now, you are viewing a lot of different race bars, as we call it, race bars. So they're kind of a data visualization effect on kind of an interactive graph plotting. And when you're making presentations, or maybe you need a better way of showing or visualizing the data, just like the COVID-19 cases, and you want to see different the rate of COVID-19 cases surges of different countries, then you can try to use this kind of visualization method to maybe bring something to present your findings. So without further ado, let's get started. As I've just mentioned, we will be using a bar chart race module inside Python. So to install that, we just need to do pip install, or if you have Anaconda installed in your device, then you can just copy this command and download this library. And okay, so for the data set, we'll be using the data provided by John Hopkins University in the United States. So the data set will be consisting of provinces, countries, the latitude and longitude, which we won't be needing for now, and also the time series. So this is the main part. We can see the surges of numbers when we go through the different dates. So let's get started, shall we? Another point to note is that some of the countries contains different provinces, and there are data specifically for that provinces. So we will be doing some kind of data manipulation and combine these two into a single value, so we can accurately represent the situation. So without further ado, let's get started. So let's jump into the code. First, we'll be needing pandas module. So let's import pandas like last episode. And we'll be needing also the bar chart race module, and we can import it as bcr. And I've assumed that you have downloaded the data from here. And if you don't know where is it, I will put a link in my description so that you can get access to this data set. And as I believe that this data set will be updated every day, so you can have a better representation of the recent number of cases as well. So yeah, that's the plus. So let's put it inside the data frame. We read the CSV. I've named it as the time series COVID-19 confirmed global, I believe is that file. Okay, so let's check. So yeah, we have the dataset loaded inside data frame df. Okay, so we won't be needing the latitude and longitude, so we won't be needing the columns. So let's do df.drop those columns, and we'll be dropping 2. So let's make it a list, lat and then longed. Okay, let's check. So the 2 columns are removed. Okay, nice. And we can kind of combine the province row, province/state row, and the country's regions into the same and make it a new column called location. So it's basically if it contains something like, wait, let me try to print out more data. So if in this case Australia has the province Australian Capital Territory, right? So the new location will be Australian Capital Territory and then comma space Australia. Okay, so how do we do that? Let's try. So we'll be combining the province and the country and make it into a new column. We call it place or whatever you want to call it. Call location, doesn't matter. Location. So we get province slash state, and also the country slash region. And then we do apply. Apply what? We'll be applying a lambda function. X. And then comma space. Dot join. So bear with me, I'll explain the whole piece of code later on. So let's check. X is equals 1. Let's see. Okay. It became the last column. As you can see, the location, and notice that we have added a new function here. It's called x.dropna. So basically there will be some NaN values without, so it's just Afghanistan without the provinces data. So we can just ignore that. We can just drop it using this x.dropna. We're assuming that we join those countries, such as like the Australian case just now. You can see over here Australian capital and then comma Australia. So it's kind of clean now. So the whole function is basically we apply this whole function inside. Yeah, and then we get these two columns. Okay, and then we won't be needing the province and the country columns because we have the new location columns, right? So let's just data frame equals data frame dot drop columns, just like the longitude and latitude case. Province slash state, sorry about my typing, and country. Cool. So let's check. And yeah, the first column becomes the first date. And for the combined, move the combined values to the first column. So as you can see, now the location column is the last. So we can just use a quick little 3 lines of code to make it happen. So data frame dot columns, and then columns equals columns -1, and then plus columns df colors. So basically we just get the columns, all the columns inside data frame, and then put it inside this variable, and then make it a list as well. And then we just append the last, make the last column, and then put it in the first place as the first item. So, and after we do this, the the last column becomes the first column. Let's check. Wait. Oh, so we will be needing another bracket here, I think. Oh, I'm missing a column. Yeah, that should work. So a special note for this library, the bar chart race library in Python, is that the index column has to be in terms of date, and the header columns needs to be in terms of the variable that you want to plot. So in this case, it will be the countries. So as you can see, the time series is here. The data is incrementing row by row. So for the data set now here, it kind of switch it up. So the rows are actually the countries, the header columns are the dates. So what we have to do in this case is to turn the columns, the header columns, into the rows, and then turn the countries and the rows into columns. So we basically do a transpose function. It's kind of similar to a matrix where you turn the rows into columns and then the columns into rows. So in this case, we'll be creating a new transpose data frame. Transpose, which is just simply .t. Yeah. And then data frame transpose dot columns equals data frame first, and we can check the data frame first to see. So when you do the transpose, you can see that the header columns are in terms of 0 to 271. However, we want the first row to be the header value of the columns. So what we have to do is just data frame transposed dot columns equals data frame dot transpose dot ilog dot to list. So you can see the columns here. You can see we get the first row, the data of the first row, and then we put it inside the data frame as the header values. So we do that by data frame transpose dot df transposed and then ilog first. So we can see the new data frame is turned into here. So it's similar to the example data frame shown in the official site of this library. Okay, and then we have to label the index as date. So here there's a date label, and we're missing a date label here. So we can just do that by data frame transposed dot index dot names, and then set it equal to date. Yeah, here. So let's see. There we go. And the next part is to specify the countries to be included for data pre-processing. So what I mean by that is when you take a look at the data set, so there are hundreds of countries, and for each row, so for each countries, there are actually hundreds of data points. And for this massive data set to to be plotted, it may take hours for the whole thing to finish plotting, and if you just want a quicker representation of the big players, for example the countries, maybe Germany, Spain, United States, India, Brazil, those countries with the most cases, then we can specify these countries and then do data preprocessing. So the whole process can be speed up. So let's do columns. We can specify these countries and then copy it inside here for the rows, for the columns that we are interested in seeing, and we do a subset. Columns, and I chose Hubei, China here is because allegedly the coronavirus was originated from here, so I want to see the kind of the demonstration or the whole start of coronavirus. The cases surges inside here will be the first one that we're interested. So let's see the subset. Okay, so we extracted the data frames for the countries that we are just interested. And the reason why I do Hubei, China here is because allegedly the coronavirus was originated from Wuhan, which is inside the Hubei province. So let's see if at the start of the plotting, maybe Hubei will have the most number of cases, and then see how the things turn out. So let's see what the subset does. So for the subset, we just kind of extracted the data frame for the countries that we're interested in inside the columns. So it's basically a subset of data frame.transpose. So for the next part, we will create a new data frame and then make sure all the cells are in numeric form. Okay, so let's do that. We can do sum cumulative sum dot data frame equals the subset dot cumulative sum, and then set the axis equals 0. And we have to make sure that the whole data frame has to be in numeric values for the whole library to work, because they will be ranking the countries day by day. They will be ranking the numbers of cases day by day. So we have to make sure that they are not strings or any other kind of format that is not numeric. So we do pd dot to numeric, and this is kind of an built-in function from pandas. So let's see, cumulative sum dot data frame, and cumulative sum is not defined. Let's see. Oh, just a typo. Okay. Oh, it's it's just a silly typo here. let's say cool. And we have, for the last part, we have to turn the index to datetime objects. So I will explain this later, why it's necessary, why this is necessary. And so for the next part is to turn the index, so the index to datetime objects. So this is important, but I will mention it later. But let's do it now first. So data frame.index, and then we do the built-in function pandas dot to datetime, and then we put in the index. Okay. So hopefully it will turn that this column, the index column, into datetime objects, which is essential for the plot later on. So for the main part, we have to specify is to call the BCR object, and then .b bar chart race. So there's a number of attributes that we have to pass on. We have to first, it takes in a data frame, so we do data frame dot cumulative sum, which is here. You can just copy and paste. And for the title, let's do COVID-19 case by country. And if you wish to save the file, the plot, the whole file into an MP4 format, then you can just do file name and then specify the file name inside here. So it will be saved inside the current directory that you're in. Let's do visualization. .mp4. And for the next variable, we do period format equals to this format. So it's essentially just month, the date, and the year, but the month is displayed in January instead of just 1. So this part, in order to use this part, in order for the bar chart race library to recognize this form and recognize the datetime objects and turn it into this format, so it's basically, for example, it's just April 1st 1, and then 2020. We have to make sure that the index row, index column has to be a datetime objects for this to work. Otherwise, it will be shown as just this kind of dates format. So they will be incrementing the dates based on here instead of the format that you specify. So yeah, and we can specify how many bars that are displayed inside the chart. So we don't want to see 10 bars at once, so we want to see the top 8 bars. And then for the next one is the steps per period. So you can just think of the steps per period as the frame per second. So essentially, more steps per period, then the more smoother the plot becomes. And for the interpolate period, we can set it to true. So essentially here, and we need to look at the tutorial, and then you search interpolate period. It's basically increasing the every frame by 1. So if you do higher, if you set it to true, then it will just increase the speed of the plot. So, and you can see that for the if you read the documentations, there are actually a lot of attributes that you can control the plot. You can do ascending bars. You can do ascending bars. You can limit the number of bars, just like we did it with n bars equal to 8. And then for the interpolate, you can increase the speed as you reaches the end of the plot. Yeah. And there are different properties. You can change the figure size, and you can label the bars, you can set the title, and then you can set the period label, which is this label here. Yeah, there are a lot of customization for the bars, and you can just read the documentations. And I think the documentations are actually very clear. And yeah, and that's basically it. So let's plot it out. File name, oh, we forgot the comma. And you may see the user warnings here, but it doesn't stop you from plotting. And I believe it's just some kind of error inside the package. And it takes some time for the plot to load, and if it finished plotting, then I will show you the result here. So after the program finishes plotting, then I can just open the current directory and then see COVID-19 visualization.mp4. So let's check it out. So as you can see, in the first stages when the coronavirus was discovered, most of the cases are from Hubei, China. Hubei is a province in China, and I believe the coronavirus was originated from Wuhan, China. So the province has the most number of cases. The majority of cases are from there. And Italy, Spain, US are catching up. US cases are growing exponentially, and the growth rate is much higher than every other countries listed here. And Hubei is declining in position. Countries are slowly catching up. And we can fast forward this a little bit, and you can see Brazil also catching up. And US has passed the 1,000 million case mark before July 2020, so it's actually growing at an alarming rate. Brazil and also India are catching up. In late August, and I believe India also passed Brazil in the number of cases. I believe it's near October, I guess. Yeah. Yeah, so you can see late October, India passed and then become the country with the second most COVID-19 cases, and US is still miles ahead of the curve. So to the more recent cases, so US has passed the 2 billion case mark, and that's it for now. If you enjoyed this tutorial, then please give a thumbs up and let me know if you want to see any more data manipulation or pandas or Python tutorials. My name is Andrew Fung. See you next time.